And today we are going to do 9C, lesson 9C, and we're going to be talking about solving equations that have radicals in them. And the first thing that I want to do is I want to just use this slide for a minute to show you guys how to find the button that you're going to need on your calculator. So if you're using one of my calculators in my class, this button right here, let me get this button right here that looks like that with the little rooftop. I call it the rooftop. That's our exponents button. And right above it in blue is a button that looks like this. You can't really see it on this page, but it looks like this. It has a little X with a radical behind it. And that is the button that I want to use if I want to do a cube root. So right here is a square root, and both of those are in blue. And if I want the things in blue, what I need to do is I need to push the blue button first. So I'm going to push second function and then one of these buttons. If I'm taking the square root, let's just do this. If I'm taking the square root, then I can use this button. If I want to take the cube root, I have to do a couple of things first, okay? Let me erase for just a second. If I want to take the cube root, the first thing I'm going to do is I'm going to put in the 3. Because what I'm telling my calculator is what this number should be. So I'm going to push 3, then I'm going to do, so that'll be the first button that I push. Then I'm going to push second function. That's the second one. And then I'm going to hit the arrow right here. That'll give me x square root. That's the third button that I push. And then I want to type in whatever I'm taking the cube root of. So then I would put in like 216 or 125 or whatever number I'm taking the cube root of. So the fourth thing is fill in this part of my equation with my number. So that would be number 4. Okay, whatever number I'm taking the cube root of. So I'm going to push 3, second function, cube root, and then type in my number, 216, 125, whatever number I'm taking the cube root of. So you might need something like that. If you're using a computer or a calculator at home, it's kind of probably the same idea for most calculators, but you're looking for that button that has a little X there. That's the button that will do cube roots or any other roots, fourth roots, fifth roots. It'll even do square roots. We just have to tell it that that X would be a 2 instead of a 3. Okay, so there we go. Okay, moving on. Let's talk about today's stuff. I can solve radical equations. I can solve equations that have radicals in them. So there's a couple of little tricky things that are going to happen sometimes once we start working with equations. And one of the things that we want to check or look for are what happens when I start getting negative signs. And if I have a negative on the outside of my square root, that's okay. That works. And the way that it works is I'm going to take the square root of whatever number is here, in this case 9. So I take the square root of 9 and get 3, and then I make it negative. So when the square root is on the outside of the radical, it's just saying it's a negative square root of a number. When the negative is on the inside of the square root, this is no solution. I cannot take the square root of a negative number. And the reason why is if I square a number, I get a positive result, right? And even if I have a negative number and I square it, I still get a positive result. If I have a negative and I square it, remember my exponent goes first. So this would be take the negative of the square root. So that's where this comes from over here, right? But the negative is kind of like on the outside in this case. If I'm squaring a negative number, if I'm squaring a negative number, it's always going to come out positive. So in order to get a negative square root, that cannot be done. We call that a no solution. It's actually an imaginary number. We talked about the real number system and in this unit, and one of the other number systems is what's called the imaginary number system. And you'll talk about that later when you get into higher levels of math. But a negative square root is an imaginary number. So in our case, if we ever end up with something like this, the square root of a negative number, we cannot do that. We cannot calculate that in the real number system. So we're going to say it's no solution. All right, so the last thing is, can I take the cube root of a negative number? And so think about this. If I take a -2 and cube it, right, what's happening is I have 3 -2's getting multiplied together. And so when I am cube rooting, this actually works out to be a -8. So that's fine. I can actually take the cube root of a negative number. It just means my root is a negative answer. So here in this case, my cube root of -8 would be -2 because there's my group of 3, right? That's what I multiplied together to get -8. So a cube root of a negative number works just fine. That's okay. And a couple of little tricky things that we start to see when we are working with equations. There's a couple of other things that we're going to talk about today that we're going to want to remember. And so as we go along, make sure you're filling in your notes and writing these little things down that we want to remember. And anytime I write something like this, remember, right? Then that is something really important to put in your notes. So remember, right? Remember that if I have a negative outside, right, then my root is going to end up negative. If I have a negative inside, it's no solution. And if I have a cube root with a negative inside, it's okay. Solve it. All right, my answer is going to end up negative. My root is going to be negative. My root is negative on those. Okay. Let's talk about inverse operations and how we solve equations. Okay. We're going to kind of take a look at some of these. Inverse operations are opposite operations. Inverse means opposite. And remember, when I'm solving an equation, if I have something like this, x plus 2 equals 6, how do I solve it? What do I do? Well, remember, the first thing that I want to do is draw my line, right? And then my goal is to get x alone. So in order to get rid of the plus 2, what do I have to do? Minus 2. And if I'm minus 2 from one side, I have to minus 2 from the other side. Well, what happens right here when I add 2 and minus 2? Hopefully you're thinking they cancel each other out. They go to 0. Why do they cancel each other out? Because they're inverse operations. They're opposite operations. And so we use opposite operations. We cancel things out, right? And so my answer here would be x equals 6 minus 2 is 4. X equals 4. I use the opposite operations to cancel each other out. Well, same thing would work, right? Let's say my original equation was a negative instead, right? X minus 2 equals 6. Well, how would I cancel that out? I'd add 2 to both sides. And so that would cancel out. And in this case, I would get x equals 8. So remember, I can use those opposite operations to cancel each other out. Addition and subtraction are partners. They can cancel each other out. Okay, what about multiplication and division? I'm just going to give myself a little bit more room now. Oh, shoot. Now I've moved that all around. There we go. Let's lock this guy in place. Then he won't slide around on me. Okay, so what if I have 2 times x? 2 times x equals 6. How do I undo multiplication? What's the opposite thing? How do I cancel out multiplication? I use division, right? And whatever I do on one side, I have to do on the other. These cancel each other out. Why do they cancel each other out? Because these are opposites of each other. They cancel. Oops, there we go. Okay, so then I would have x equals 3. And remember, the thing about having an equal sign in my equation is it's a scale. And whatever I do on one side, I have to do on the other side to keep it equal. Okay, does it work the other direction? So if I have x divided by 2 equals 6, how do I cancel division out? Well, I've got to multiply both sides by 2. That's going to cancel out, and I would get x equals 12. So either way, if I multiply first or if I divide first, it doesn't matter because addition and subtraction are opposites and multiplication and division are opposites. And it doesn't matter which direction I'm going, they're always going to cancel each other out. So let's take a look at these. I better move this guy back. Oh, I've got a little trouble here. Let's delete him. Okay. So what about, we talked about this a little bit last time, right? What about the exponent of 2 and the square root? What if I said x squared equals 9? How do I cancel out an exponent of 2? And we kind of talked about this last time we were in class. Well, the opposite of an exponent is a square root. If I take the square root of x squared, these things cancel out. But whatever I do on one side, if I take the square root of x squared, I have to take the square root of the other side. And so x is going to be equal to the square root of 9. And so I would take a look at some of my charts that Ms. Miner and Mrs. Zider have provided you in your notes and find what would be the square root of 9. Now, if I use my calculator, great, as long as it gives me an exact answer. And if I put the square root of 9 into my calculator, it's going to give me 3. What if it gives me an irrational number? Well, then I have to factor it out, right? Find my group of 2, and that's going to be my root. So hopefully you've practiced with your assignment from 9B, finding the exact square root, because if we need the exact square root today, we're going to have to factor it out and make sure we find the exact square root. But my point here is that the exponent of 2 and the square root, they are opposites, and so they will cancel each other out. So what if we go the other direction? What if I start with the square root of x equals 9? What if I start with the square root? How do I cancel out the square root? Well, just like any other inverse operation, I do the opposite thing. If I have a square root, then in order to cancel it out, I have to square it, right? I want to get x by itself, so I'm going to square my square root. If I square one side, then I have to square the other side. And these will cancel each other out. I'll be left with x. Over here, I have 9 squared, which is 81. Now, feel free to do this in your calculator, 9 raised to the second power, to figure out what that is. So a couple of things are happening here, remember. One, I'm using the opposite, which is the square root, to cancel out the exponent, or I'm using the exponent to cancel out the square root. And it works both ways. in order to get x by itself, what opposite operation can I use in order to do it? Okay, well, guess what? If I have an exponent of 3, I also have a cube root, and those two are opposites of each other, and they will cancel each other out as well. So let's just see how that works. If I have x to the third power, it's going to, let's say it equals 125. X to the third power equals 125. If I want to cancel out a third power, I have to use the opposite operation. So here's my equation. On one side, I'm going to take the cube root. That means I have to take the cube root of the other side. The cubed and the cube root cancel out, leaving me with just x. And then over here, I'm going to factor out 125 into, 5 times 5 times 5. There's my group of 3. My cube root is 5. Okay, so hopefully you've been practicing your cube roots, practicing your square roots, so that you kind of know what I'm doing over here. Make sure you use your charts. If you need your factorization charts, you're welcome to use those to help you find the factors of any number that you're taking the cube root or the cube of. Okay, so let's go the opposite direction. Let's solve an equation that has the cube root of x. Let's start there. The cube root of x equals 2. How do I get rid of a cube root? I use the opposite operation, which is give it an exponent of 3. If I give an exponent of 3 to this side, I have to give an exponent of 3 to that side. And so this is going to cancel that, leave me with just x. 2 to the third power is the same as 2 times 2 times 2. So x is equal to, I'm going to slide this down, 8. 2 times 2 times 2 is 8. Be careful not to just do 2 times 3. Remember, my exponent tells me how many 2's I'm multiplying together. So 2 times 2 is 4, times 2 would be 8. Okay, so solving equations with opposite operations. Now, here's going to be the tricky part that you're just going to have to, this is one of those things you're going to want to write in your notes to help you remember. If I ever have an equation that looks like this at any time while I'm solving, if I end up with x squared equals 9, well, think about the numbers that I can square that would give me a positive 9. And we kind of talked about this at the beginning, right? I could square a 3. And let's just solve this the way we normally would, right? What I want to do is take the square root of both sides. And so the square root of x squared, that's going to cancel with that and leave me with x. And then over here, if I'm going to take the square root of 9, I'm going to get my factors of 3. There's my group of 2. So my square root is 3. And that's what we would come up with if we just solved it like we normally would. Okay? And we're not wrong. That is the answer. X equals 3. However, if we think about back at the beginning of our lesson today, I said that I could also square a negative number, and it would also come out positive. If I took negative 3 and squared it, it would also equal 9. So 3 squared equals 9, and negative 3 squared equals positive 9. Both of those things are true. And so it doesn't happen with any of these other kinds of equations where I have the square root or I have the cube root. Remember, the cube root kind of was different as far as negatives and positives were concerned. But the only time, and this is a note you're going to want to make big and circle it maybe. This is what you want to remember. Remember. Maybe circle this equation right here. Kind of make yourself a big star so that on your test or on your assignments, if this kind of happens to you, I got to move that guy. Oh, let's just delete him. What I want to remember is whenever I take the square root of x squared, if I'm taking the square root of x squared, then my answer is going to be both positive and negative. And this is kind of how we do it. Remember how I solved this before? I said, okay, I'm just going to solve this like I normally would. Take the square root of both sides. This cancels out. X equals 3. Whenever I see something like that, I'm just going to put in a plus and a minus. And we do it just like that. We put in both. We give it a plus and a minus sign. We just kind of stack them on top of each other just like that. And then we say it's plus and minus 3. If I'm ever taking the square root of x squared, my answer needs to be both plus and minus, because I don't know what this number was when I started. There's no way of knowing if I squared a negative 3 or if I squared a positive 3 to get that 9. It's both. And so I'm going to get two answers. Whenever I see something like this. And it could happen at any time in my problem. At any time in my problem, if I have to take the square root of x squared, then I have to remember that the answer is both positive and negative. You're welcome to write it like that, or you're welcome to just write it like this. X equals 3, x equals negative 3. So you can write it like that if that makes you feel better, or normally just for quick and easy, we write it as both. So don't forget about that. That's kind of a little tricky thing that we have to remember. Okay, let's go through. What I'd like you to do is pause the video, practice solving some of these other problems that are in your notes, and then come back and check your work and see how you did. Okay, hopefully you went through and you solved some of these other problems. I'm going to slide this one down just so I have a little bit more room. And we're going to finish solving these just to see how we did. Okay, so I have a square root. What cancels out a square root? Hopefully you said a squared. And if I square the left side, I have to square the right-hand side. That's going to cancel out. And so x is going to be equal to 6 squared, which is the same as 6 times 6, which is 36. Okay, now this is one I want to talk about over here. 4 equals the square root of b, because sometimes our eyes play tricks on us. And I have a lot of students who see this one and they automatically are like, ooh, square root of 4. I got to square root both sides, right? But remember, that's not what I want to do. When I'm solving equations, I have to cancel out the square root. And so what I need to do is square it in order to get b. B's kind of like, I always say the square root is kind of like B's in jail. And I have to free him. I have to get him out of jail before he can tell me what his number is. And so in order to get him out of jail, I have to square both sides. So be careful about that. Don't let your eyes play tricks on you. And so this is going to cancel now with my square root and leave me b. And this is going to be 4 squared, which is the same as 4 times 4, which is 16. Okay. And then last but not least is this one over here. Same idea. Don't let your eyes play tricks on you. If I start with a square root, the opposite of that is squaring it, right? And so I'm going to square both sides. And the squared will cancel out the square root. And I'm left with 25n equals 5 squared, which is the same as 5 times 5. That gives me 25. Now, wait a minute. I'm not done. I have another step now. I have 25 n's over here, and I need to have just one n. So how am I going to get rid of this 25? Well, remember the 25 in front is always multiplying the n. And so in order to cancel out multiply, I have to go ahead and divide. If I divide, I got to divide both sides. This is just regular equation solving. So that's going to cancel, and n is going to be equal to 25 divided by 5, which is 1. So sometimes we got some extra steps in there that we have to be able to solve. Okay, these are just cube roots. So we're going to do it the exact same way that we did before. I'm going to look and see what I started with. Cube root of, m cubed. Well, there's where I started. I want m by itself. How do I get rid of an exponent of 3? With a cube root this time instead of a square root. So I'm going to take the cube root. That means over here on this side, I have to take the cube root. These two things are going to cancel each other, and m is going to be equal to the cube root of 216. Now remember how to put that in your calculator, right? I have to put in the 3 first because I want to tell my computer, I want to tell my calculator what root I'm taking. So I'm going to push in the 3, and then I'm going to do second function. I'm going to hit my exponent button, which was the little rooftop, and then I'm going to put in 216. And that tells me that my cube root is 6. Now the other way that I could do this is I could factor it, right? I could factor this out. And if I do that, what I'm going to get is, or if I use my cheat sheet, what I'm going to get is 2 times 2 times 2 times 3 times 3 times 3. And so what's going to come out of my factors? A 2 and a 3. And so the cube root is 6. 2 times 3 is equal to 6. So if I use my cheat sheet and find my factors, I want to make sure that I'm figuring out what the cube root of 216 is. Okay, well, let's take a look at this next one. What if I start with a cube root? Well, I'm going to cancel out a cube root with an exponent of 3. That means I have to give an exponent of 3 to the other side of my equation. And the 3 is going to cancel out the cube root and leave me with n. And then this is 4 to the third power, which is the same as 4 times 4 times 4. So n is equal to 64. Now I can just put this in my calculator, 4 raised to the third power, or I can go ahead and multiply it. Okay, here's another example. This is a little bit different. We have to kind of remember about how we're solving an equation. So remember before when we had a hostage. Remember if I have something hanging on here, right? It's almost like that guy is saying, hey, don't go without me, right? I have to undo all my addition and subtraction before I can undo multiplication and division. So I call this guy over here my extra hostage. I call him my extra hostage, and he always escapes first. But really what we're doing is we're thinking about our order of operations. And when I'm undoing, or when I'm solving an equation, I'm basically undoing the order of operations. And so I have to undo all the addition and subtraction first. Then I have to undo all the multiplication and division, and then I have to undo the exponents. Okay, so if I were doing just this problem, right, this guy would go first. Well, same thing's happening over here. This guy's got an exponent hanging on to him, right? And so I have to undo my addition and subtraction first. So I'm going to get everything kind of away from my x variable first. Get him alone. Okay. So the first thing I want to do is cancel out the subtraction and add 6 to both sides. Then take a look right here. I am going to take the square root of x squared. What did we say we had to remember about the square root of x squared? Remember, how many answers should I get if I take the square root of x squared? I should get 2 answers, one positive and one negative. And so this is a great example of what I'm talking about. Here's the square root of x squared. In order to cancel out the squared, I have to take the square root of both sides. I'm going to take the square root just like I normally would. I'm going to look up the factors of 16. And this is going to come out, and this is going to come out. And so x squared is going to cancel the square root, and I'm going to get x is equal to 2 times 2, which is 4. And then I'm going to say it's either positive or negative. I don't know which one it is, so I say it's both. Now, if I had some context to this, if I knew I was talking about the length of a square or something like that, if I knew what I was talking about and I had some context to it, then I could probably decide if it was going to be negative or positive, right? But because we don't have a context to this, we don't know. And so we say that it could be both. Could be a -4 or it could be a +4. Okay, so be thinking about that. Now, is it the same with a cube? Well, it wouldn't be the same with a cube. It couldn't be positive or negative because with a cube, remember, I'm going to either have all positives or I'm going to have all negatives. If I have all negatives, I'm going to have a negative answer. If I have all positives, I'm going to get a positive answer. And so with a cube, it's a little bit different. And so we don't have to say both positive and negative with a cube. We don't have to worry about that. Okay. So let's do a couple of problems here just to kind of get a few different examples. Here's my equal sign, and here's this. What do I do first? Do I take the cube root first, or do I get rid of the 25 times b to the third, right? Well, remember my order of operations, right? My order of operations. And when I'm solving, I'm working backwards through the order of operations. So if I have any addition or subtraction, I get rid of that first. If I have any multiplication or division, I get rid of that first. Then I deal with exponents. So since this is 25 times b to the third, I got to get rid of that first because I'm undoing. And so I'm undoing multiplication and division before I get to the exponents. So I'm going to take this, I'm going to divide by 25. I'm going to divide by 25. Those are going to cancel, and then I'm going to have b to the third is equal to 1. And the last thing that I can do is take the cube root of both sides. The exponent of 3 and the cube root will cancel out, leaving me with just b. And the cube root of 1 is just 1. So there's my answer. Now I have to think about something that's going to be also a little tricky. And so here's another thing that we're going to want to remember. And so let's make sure we make a big note. Let's make a big note in our notes that says remember. And then maybe let's circle this problem right here. Because here's another little tricky place where we're going to want to remember a rule, okay? And the rule is that the square root works like parentheses. It's a grouping symbol. Remember when we said a fraction bar was a grouping symbol? Well, a fraction bar is a grouping symbol, parentheses are a grouping symbol, and a square root and a cube root are grouping symbols. And if I see that this square root is covering more than just one thing, then all of those things are being grouped together. They're being held together. I call that jail. This is what I call jail. Remember, jail. Okay? And if things are in jail, I have to get them out of jail before I can do anything, right? If all my buddies are in jail, I can't hang out with them. Can't do anything with them. I got to get them out of jail first before I can do stuff with them. So if I have a square root, then I have to, well, let me change colors here. Then I have to cancel out the square root first before I can do any moving across the equals sign. So the first thing I'm going to do here is get rid of the square root. Get those guys out of jail so that they can be moved around and I can get x by itself. So remember jail. If the square root is grouping, cancel it out. Cancel it first. So if the square root is grouping, cancel it out first. Remember jail. Okay. So I'm going to square this first. That means I've got to square this side first. And then this 2 is going to cancel out. This whole square root is going to be gone. And then my friends are free and I can work with them. 3 squared is 9. And so I can finish solving this. Equation at that point. These are going to cancel out. And I have 2x is equal to 1. I want to move all my stuff down just a little bit. Let's give myself a little bit more room here. And then the last thing that I would do is divide by the number connected. And so x is equal to 1/2. Okay, so remember jail. If the square root is grouping, we have to cancel it out first. All right, here are some square roots that are grouping, right? They're grouping stuff on that side and they're grouping stuff on the other side. Well, anything that's in jail, right, I need to cancel out those square roots. What do I cancel out square roots with? Squareds. I'm going to cancel these out. I'm going to square both sides. And then what happens is both of these square roots on both sides cancel out. And so what I'm left with is the stuff on the inside. And then it's just a regular old equation like we've been solving all year long. I can subtract 3 from both sides. And I'm going to get m is equal to negative m minus 4. I can add m to both sides. These will cancel. Negative 4 is equal to 2m's. Divide by 2. And m is equal to negative 2. Okay, so I'm just doing regular old equation solving there. I didn't do anything fancy except for maybe the very first thing that I did up here where I canceled out the square roots with squareds. Okay, now most of those questions, if you've been following along with this video and you've been taking notes, then most of the questions that we did as examples in this lesson, they're on your homework assignment. And so you can go back and just copy some of those onto your homework assignment. Let's do one more just for practice, just so that we can make sure we're all on the same page. Okay, last one. What I want to do is I want to get rid of my extra hostage first. There's nothing, they're not in jail, right? And so I'm just going to cancel out this first. This is going to cancel. There's my canceling. And a squared is equal to 169 minus 44. I'm sorry, 169 minus 144, which gives me 25. Now, the next thing I want to do is I'm still looking over here where my a is, right? My goal is to get a by itself. Right now I have a squared, and so I'm going to, not square it. I'm going to take the square root of a squared. What did we have to remember about when I take the square root of a squared? Well, I got to remember to do it to both sides. But I also have to remember that my answer is going to be both plus and minus. So be careful about that. Be looking for those little things that we have to remember. A squared is going to cancel out the square root and leave me with just a. And the square root of 25 is equal to 5. Oh, and don't forget, plus and minus 5. Okay, so there we go. I almost forgot, but then I remembered. So be thinking about those things that we need to remember. Make sure you have those in your notes so that you're referencing. When I see a problem like that, it will help me remember. Okay, good luck, you guys. If you have questions about this, make sure that you're emailing me or Mrs. Zeider, and we are looking forward to helping you guys with this. Okay, thanks. Bye.